take benzene ring. Okay, this benzene ring added with CH2, CH2, NO2 like this. Okay, we know that CH3NO2 as nitromethane. Into that nitromethane, just replaced by one phenyl group. That is, first carbon this is, second compound this is. CH3NO2 means nitromethane. CH3CH2NO2 nitroethane. In that, second question is occupied by a phenyl group. Second question is occupied by a phenyl group. So if you take a compound, okay, second question is phenyl group. So you choose the prefix 2-phenyl. Choose the prefix 2-phenyl. And the first question is occupied by a NO2. So that is also prefix because nitro group we are choosing as a prefix. 2-phenyl, 1 nitro. How many carbon? 2 carbon. So the root word 2 carbon, root word and primary suffix a. So and we combine this, the prefix we choose 2-phenyl, 1 nitro, and the root word a and the primary suffix a. So on combine these we will get 2-phenyl, 1 nitro methane. Okay, this is how you have to give the name to the organic nitrogen compound. So how to give the IUPAC name? So first we should select the nitro group acting as a prefix, and next we have to choose a root word. That is the root word choosing is based on the number of carbon atom, and next we have to choose a primary suffix. It is based on whether your compound is saturated or unsaturated. On adding this whole compound, you are going to get. That is called as a nitrogen compound. How to give the IUPAC name is here. And next, you are going to see what type of isomerism possible in the nitrogen compound. So usually isomerism in all the compounds, okay, we can expect the isomerism. So first of all, what is isomerism? Same molecular formula, but differ in the nature of the compound attached. Whether chain isomerism means we can change the carbon skeleton. Position isomerism means we can change the position of the functional group. Okay. Functional isomerism means we can change the functional group itself. Okay. In addition to that, here we are going to see what is tautomerism also. Okay. So first of all, we can see one by one. What are the isomerism possible in the nitrogen compound? So first, isomerism possible. So first, you can see chain isomerism. So first, what is chain isomerism? Same molecular formula. Molecular formula. Same. Different carbon skeleton. Different carbon skeleton. Okay. Same molecular formula but different carbon skeleton. That is only named as a chain isomerism. Okay. So if you take a compound, nitro compound, CH3, CH2, 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 NO2. Okay, you take this compound. So where the nitro group is attached with the first, which position? You have to check which position the nitro group is attached. Here the nitro group is functional group. This is the first carbon, second carbon, third carbon, and fourth carbon. How can you give a name? Here the first question nitro compound attached. Okay, so prefix is clear, nitro. And next, what is the root word? So root word based on 4 carbon bute. Whether a compound is saturated or unsaturated, saturated. Saturated means A. So first write the prefix. So prefix question is first question. So 1 nitro root word bute. Primary suffix A. So the compound name is 1 nitrobutane. Okay, this is a compound. Now, how this compound exhibit chain isomerism with another compound? Those compound also having the molecular formula same, but we can have a different carbon skeleton. But how this? So take CH3, CH3, CH2, NO2. Okay. What is this compound name? Nitro group is functional group here. So attached carbon 1. Next carbon 2. Next carbon 3. The second question methyl group is attached. First carbon nitro group is attached. So the compound name is 2 methyl. Okay, second question methyl group. 1 nitro. First question nitro. How many carbon in the main chain? No need of taking a side chain. Main chain how many carbon? Only 3 carbon. So 1, 2, 3. So prop is a root word. The compound is containing only single bond. So the compound is saturated. Use A. So what is the compound name? 2-methyl 1-nitropropane. 2-methyl 1-nitropropane. This is a different compound. And you see the structure. This is 1-nitrobutane. This is 2-methyl 1-nitropropane. Let us see what is that 2 compound. Find the molecular formula. Here, how many carbon? The first compound, how many carbon? There are 4 carbon. Okay, so 4 carbon. C4. How many carbon? 4 carbon. How many hydrogen? 9 hydrogen. And NO2 group is attached. In this compound, that is 2-methyl 1-nitropropane. In this compound, how many carbon? 1, 2, 3, 4. There are also 4 carbon. How many hydrogen? There are also 9 hydrogen. How many nitro group? Only 1 nitro group. Let us check. These 2 compounds having the same molecular formula. Molecular formula means clearly indicating how many carbon, how many hydrogen, whether how many nitrogen, how many oxygen. Individual element, how many present, that will be taken as a molecular formula. These 2 compounds having the same molecular formula. Formula is same, but different carbon skeleton. Here we are choosing 4 carbon in the state chain. Because if you want to give a IUPAC name, the first you have to choose the longest carbon. That longest carbon chain should contain the function group. Here we are choosing longest carbon chain 4. But in the second compound, we are choosing a longest carbon. But the longest carbon chain containing how many carbon atoms? Only 3 carbon atoms. So these 2 compounds will have the change in the carbon skeleton. That's why it is given the name of the isomerism. Chain isomerism. So what is chain isomerism? Same molecular formula, but different carbon skeleton. Same molecular formula, but different carbon skeleton. So that is only given the name as what? Chain isomerism. Okay. And next, we can see the second isomerism. The second isomerism is position isomerism. What is the name of the isomerism? Position isomerism. So what is position isomerism? Same molecular formula. That is molecular formula same. Okay, molecular formula same. Same functional group, but differ in the position. Differ in position of functional group. Differ in the position of the functional group. Let us take an example. For example, you take the compound CH3, CH2, 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 NO2. This compound. Okay, how can I give a name? A nitro group is attached first carbon, second, third, and fourth. Here, carbon skeleton as straight chain. Okay, so first carbon attached with the functional group. So the name of the compound is 1-nitro because the nitro group has a prefix. You know how to give the name 1-nitro. How many carbon atom attached in the longest carbon chain? Only 4. So root word huge. Okay, huge. And the primary suffix present is A. So the compound name is 1-nitrobutane. What's the compound name? 1-nitrobutane. Okay. Next, this compound exhibit position isomerism with the second compound, that is CH3, CH. Okay. If I take CH3, CH. NO2, CH2, CH. You take the second compound. Okay, the second compound, how to give the name? Yeah, just you are moving first compound, second, third carbon, and the fourth carbon. Your second carbon is containing a functional group. Okay, but how many carbon present? 4 carbon. That is main chain. Okay, so second position nitro. So prefix as nitro. Position 2. So 2-nitro. Okay, so 2-nitro. How many carbon? 4 carbon. So 4 carbon means root word huge. What is the primary suffix? A. So what is the compound name? 2-nitrobutane. 2-nitrobutane. Okay. Now let us check these two compounds. We have to give comparison. Here how many carbon? 4 carbon. How many nitrogen? Here 9 hydrogen. Only 1 NO2. Only 1 NO2 group is present. Here if you take 4 carbon, okay, and 3, 4, same hydrogen, 9, 1 NO2. Okay. So if you compare these two compounds have same molecular formula. Molecular formula is same. Whether functional group also same. Functional group also same. But what about the position of the function group? Here, first compound, the position is first position because the NO2 is attached with the first carbon. In the second compound, the NO2 group is attached with the second carbon. So that's why same molecular formula but differ in the position of the function group. That is given the name as position isomer. If the two isomer, if you have the same molecular formula, same functional group, but there is a difference in the position of the functional group, then it is taken as a position isomer. Okay, so two isomers we have just completed. One is a chain isomerism over, and second one is a position isomerism is over. And third, we are going to see functional isomerism. What is isomerism? Functional isomerism. In functional isomerism, the two compounds having same molecular formula, but differ in their functional group. Yeah, the functional group is changed. Differ in functional group. Okay, so let us take an example. If I take a simple example, CH3 NO2. You know, this is the first starting compound. This is nothing but nitromethane. What is the name? Nitromethane. This compound exhibits, okay, functional isomerism with the compound CH3ON double bond O. It is nothing but CH3ON double bond O. The compound name is methyl nitrite. What's the compound name? Methyl nitrite. Okay. Here also same molecular formula. Here the functional group is nitro, but here the functional group is nitrite. ON double bond O. So entirely, if you take these two compounds, these two compounds have the same molecular formula, but the functional group itself changes. The two compounds have same molecular formula, but differ in the functional group itself, then we come to know that this is belonging to the functional isomerism. What isomerism? Functional isomerism. Okay. So third functional isomerism is over. And next we can see one more isomerism, that is special isomerism in nitro compound, that is tautomerism. What is that? Tautomerism. Okay. And this tautomerism, it is a special type of isomerism occur in the nitro compound. And those nitro compounds, only primary nitro compound, secondary nitro compound having alpha hydrogen. What is that? Having alpha hydrogen. We know what is alpha hydrogen. With a functional group attached. For example, if I am taking CH3, suppose CH3 I can write C dash okay, CH3 NO2. You know, this is nothing but nitromethane. This nitromethane. Okay, this nitromethane. Now, what is alpha hydrogen atom? This is functional group NO2 group. This is a functional group. The functional group attached carbon. This is a functional group attached carbon. Contains a hydrogen. Okay, this hydrogen, this is called the alpha hydrogen. Okay, but here how many alpha hydrogens? 3 alpha hydrogens are available. So, primary, secondary nitro compounds, those having alpha hydrogen only, will undergo a special type of isomerism called a tautomerism. Okay, so how this compound will exhibit tautomerism? So these two compounds, if I am taking simply what is tautomerism means, we can see that it is moving of a hydrogen from one element to the other. Suppose, for example, you take a nitromethane. Okay? This exists an equilibrium mixture. That is, the tautomerism exists two equilibrium mixture. I explain. One is nitro and second one is acinitro. So this is called a nitroform. So first one, this is named as a nitroform. Okay. When we take this nitroform containing alpha hydrogen atom. Okay. Now what is tautomerism? We have to move the hydrogen from one element to the other. Okay. This nitromethane, I can write like this structure as structure I can write like this. H C H H N double bond O foreign covalent bond and like this. Okay, this is nothing but nitromethane. Okay, now I am going to shift the hydrogen. Okay, through this bond. I am going to shift the hydrogen, this hydrogen, from this carbon to the oxygen. Okay, shift the bond here and shift the double bond towards the oxygen. When we shift the double bond towards the oxygen, here one negative sign will come. This negative sign will take the hydrogen. Okay, and this converted into light. H C, okay, here H is missing, H, okay, and next this single bond will become a double bond, N, O, this oxygen O minus, this O minus takes a proton and it becomes a OH, okay. So when we take these two structures, the hydrogen from this carbon, I am going to shift the hydrogen towards the oxygen as OH. Okay. This first compound taken as nitroform. This is a nitroform. And this is named as acinitroform. Acinitroform. And these two mixture exists an equilibrium condition. What is the equilibrium? Thus we can reverse it. That is the nitroform. I am going to convert it into acinitroform, or acinitroform we can convert it into nitroform. Okay. This acinitroform contains a replaceable hydrogen atom. Okay. So that's why the acinitroform have more acidic character. So acinitroform will have a more acidic character. Okay. So four isomerism over. One is chain isomerism, second one is fusion isomerism, third one is functional isomerism, and fourth one is tautomerism. Okay. So chain isomerism means we are just changing the carbon skeleton. Fusion isomerism means we are changing the position of the functional group. Functional isomerism means we are changing the functional group itself. And fourth one, just a tautomerism. So tautomerism just moving of the hydrogen from the one element to the another, and we are getting two forms. One is a nitro and a acinitroform form. Okay. So next we are going to see about acidic nature. Acidic nature. So if you take a nitro compound, primary, secondary nitro compound having alpha hydrogens. Okay, having alpha hydrogen. Okay, having alpha hydrogen. Okay, those two, okay, nitro compounds They are more acidic. They are more acidic due to the presence of NO2 group. Due to the presence of NO2 group. Okay. So the primary, secondary nitro compounds having alpha hydrogens, those compounds are more acidic due to the NO2 group. This NO2 group, we know that electron withdrawing group. Electron withdrawing group. Okay, so this is under electron withdrawing group. So if you take the acidic character, generally these are more acidic. If you are comparing aldehyde, okay, and the ketones, and if you take cyanides, okay, those compounds, their comparison, these are all more acidic. Okay, compared with the nitro compound is more acidic. So compared with the aldehyde, ketone, and the cyanides. Okay. If you take the acidic character, it depends upon the nature of the alkyl group is attached. If you take the compound like CH3 NO2, that is nitromethane. Okay, nitromethane. And second compound CH3 CH2 NO2, nitromethane. And third compound, if you take CH3 CH CH3 NO2. Okay, this is a secondary compound. This is a secondary compound. If you take all the compound, you have to give the comparison of acidic nature. Okay. Here, the acidic nature, okay, whether it depends upon the number of the alkyl group. When the number of alkyl group increases, acidic character decreases. Decrease in acidic character. So, the number of alkyl group increases, there will be increase in the acidic character. Okay. So, if I am taking this first compound only one methyl, here ethyl group, here it is a isopropyl group. So, when the number of alkyl group increases, acidic character should be decreases. So, this follows our nitromethane. We have a more acidic compared with the nitro. And next, third one is a secondary compound. That is 1, 2, 3. 2 nitropropane. It is a secondary compound. So, generally, acidic character will depend upon the alkyl group. When the number of alkyl group increases means the acidic character order should be decreases. Okay, so this is called the acidic character. So, acidic character, primary, secondary nitro compound. If you have a alpha hydrogen atom, those compound will have a more acidic character, and these are more acidic than aldehyde, ketone, cyanides like that. Okay, and if you take the number of alkyl group increases means decrease in the acidic character. This is called the acidic nature of a nitroalkane. Okay. Next, come to preparation. Okay. So, preparation of a nitroalkane. So, we have so many methods of preparing nitroalkane. Let us see one by one. So, first, preparation of a nitroalkane from alkyl halide. So, preparation okay, preparation of a nitro compound from alkyl halides. Okay, We know that alkyl halides means what? One alkyl group added with a halogen. Let us take an example. CH3, CH2, Br. We know that this is a bromo ethane. Okay, this bromoethane reacts with the alcoholic solution of potassium nitrite. Okay, in the presence of alcoholic solution of a potassium nitrate. Okay, and we are going to give here K and Br should be eliminated, and this NO2 should be added. So we are going to get CH3, CH2, NO2 plus KBr. Okay, so we are going to get a product nitroethane. Okay, and this reaction follows SN2 mechanism. You know what is SN2 mechanism? It is bimolecular nucleophilic substitution. Okay, this reaction will take place in a single step. Here, the nucleophile NO2 should be added with the CH2 group. In the same way, Br, that is a leaving group, leaves from its side and it is added with the K. So that's why this is a SN2 mechanism. So from alkyl halide, just we are going to prepare a one nitro-alkane system. So you have choose bromoethane. So if you have taken the bromoethane reacts with the alcoholic potassium nitrite, there will be a reaction called a nucleophilic substitution bimolecular taking place, and we are going to get the product nitroethane as a product, and additional product potassium bromide. Okay, potassium bromide. And second one, just we are going to prepare the nitroalkane from the nitration of alkane. Second one, nitration of alkane. Okay. So here we are going to take two cases we are going to discuss. One is nitration of a methane and second one is nitration of a methane. Generally, nitration of a methane, if you take, just we are passing the vapors of a methane. Okay, just we are going to mix with the nitric acid. So the vapors of a methane, just we are going to mix with the nitric acid vapors. Just those vapors we have to send, we have to pass through the metal tube. Those metal tubes are red hot condition. Okay, so first take the methane, the gas of methane mixed with the vapors of nitric acid, HNO3. Okay, HNO3, and this, okay, the vapors pass through the metal tube, that is metal, in a red hot condition at 675 Kelvin. Okay, now just we are going to get the product. One of the nitro group is replaced by a hydrogen. So CH3NO2, that is nitromethane, along with the water as a side product. Okay. So just we are choosing methane, and methane mixed with the nitric acid vapor, just we pass through the metal in a red hot condition up to 675 Kelvin. We are going to get nitromethane as a product. What is the product name? Nitromethane. Okay. And next, same way, okay, if you take another hydrocarbon, like for example, CH3, that is methane. Okay, same. You take a ethane mixed with the same nitric acid. Just we have taken the vapors of those same condition applicable 675 Kelvin, pass through the red dot tube over that metal. Okay, now we are going to get a mixture of a nitro compound. Okay, one is CH3, CH2, NO2, and another one is CH3, NO2. So you are going to get a two compound. One is a nitro. We know that already. Nitroethane because two carbon. So nitroethane. Here only one carbon. So nitromethane. Even though we get two compound, the maximum yield compound is that is 73%. We are getting only nitromethane as a product. Remaining 27 one day, we are getting a nitromethane. So possible major product is nitroethane. And there will be here in this reaction, there is a cleavation of a carbon-carbon single bond. Here there will be cleavation of a carbon-carbon single bond. And these two compounds, one is nitroethane and another one is what? A nitromethane. These two compounds occurs as form of a mixture. The product is mixture. And these two can be separated by fractional distillation. These two compounds you can separate by using of a fraction distillation method. Okay, this is the second method of the preparation of a nitro compound. Second method is what? Nitration of a alkane. Okay, and next, third we are going to see from alpha halo acids. From alpha halo acids. What is alpha halo acid means? In that alpha hydrogen, one halo group substituted means we can say alpha halo acid. For example, Cl, CH2, COOH. This is nothing but alpha chloro acetic acid. What's the name? Alpha chloroacetic acid. We know that acetic acid is CH3COOH. That alpha hydrogen is what? The C attached hydrogen. That one hydrogen is replaced by a Cl. So alpha chloroacetic acid. Okay. You take the alpha chloroacetic acid boiled with the aqueous solution of a sodium nitrite NaNO2. Sodium nitrite. Okay. And here what happened? The CH3COOH. Here the CO2 carbon dioxide should be eliminated. This should be boiled. So heating symbol. Okay. This carbon dioxide should be comes out. And the Cl added with the Na. So we'll get a product. CH2H will be added. CH3 NO2. This is boiling product. CH3 NO2 nitromethane. Additional product carbon dioxide and sodium chloride. Okay. So if you have taken alpha chloroacetic acid is boiled with the aqueous solution of a sodium nitrite, you are going to get nitromethane as a product. What's the product name? Nitromethane. This is only aliphatic nitro compound. Third method of preparation is over. So from alpha halo acids. Okay. And fourth one, okay, we are going to take oxidation of a tertiary butylamine. So fourth one is oxidation. What is the formula for tertiary butylamine? So tertiary means 3 methyl group. So 1 carbon Okay. CH3. So 3 alkyl group added and 1 NH2. This is tertiary butyl amine. Tertiary butyl amine. So oxidation of a tertiary butyl amine. So if you take a oxidation, this oxidation will be performed. That is, oxidation is nothing but just we are going to take a oxygen. But this reaction is carried out in the presence of a strongest oxidizing agent, KMnO4, potassium permanganate. Now what happens? This amine group is converted into nitro group. That is CH3, here NO2. So this NH2 group is oxidized into NO2 group and you are expecting the side product H2O as a side product. Okay. So how will we give a name to this compound? So we know that when we take a longest carbon chain, 1, 2, 3. Second position, 1 methyl group. Second position, 1 nitro group. So 2 methyl, 2 nitro, 3 carbon. So propane. 2 methyl, 2 nitro propane. So 2 methyl, 2 nitro propane as a product. So this is the fourth one, oxidation of a tertiary butyl amine by using potassium permanganate. And next, you can see the fifth reaction from acetal dioxide. From acetal dioxide. So if you take acetal dioxide, the formula, okay, if you take CH3, CH, double bond, NO, H. Okay. If you take acetal dioxide, it is treated with the compound like CF3, that is CF3 COOH. Okay. The compound name is trifluoro, that is 3 fluorine group. So trifluoro peroxy, that is trifluoro. This is peroxy acetic acid. So acetal dioxide treated with a reagent called trifluoro peroxy acetic acid. Okay. This acetal dioxide, it is going to convert it into, that is nothing but when we take a trifluoro peroxy acetic acid, it is nothing but the oxidation process only. So this acetal dioxide, this is the acetal dioxide. Okay, this oxide, it is converted into nitro compound CH3CH. So this will converted into CH3 CH2 NO2. CH3 CH2 NO2. Okay, now this compound, this group will undergo oxidation. This NO added alkyne. Second one, we have prepared from the nitration of the alkane. So there we have discussed two conditions. One is methane only gives a single product, except methane, other hydrocarbon will get water, the mixture of the products. Okay, those conditions. And third one, just we have prepared a hydrocarbon from alpha acid. And fourth one, we have prepared from tertiary butylamine oxidation. And fifth one, we are preparing from the acetal dioxide. So only method of preparation, 5 method of preparation. Okay. So in this class, just we have discussed about what is nitro compound. Nitro compound is nothing but what we have taken any one of the hydrocarbon, those hydrocarbon hydrogen atom, if you replace by a nitro compound, we will get a nitro compounds. And we have just taken a classification. We know that classification. There are two types. One is aliphatic and aromatic. And there we have discussed aliphatic also. There are two types of classification. Aromatic system also there are two types of classification. And next we have seen about how to give a name, that is specially department. And just we have choose the nitro R suffix and we have choose the root word and the primary suffix only possible. There also we have discussed aliphatic and the aromatic nitro compound. And next we have seen about isomerism. So nitro compound, how many types of isomerism possibilities? Chain isomerism, quotient isomerism, function isomerism, and one more isomerism we have seen, a special type of isomerism, tautomerism. And next we have seen about acidic nature of those nitro compound. The acidic nature of a primary, secondary nitro compound is due to the presence of an electron withdrawing nitro group. And then we have just noted one point as a 1 mark question, because the presence of the alkyne group, whether it is decreasing or increasing the acidic character. So the presence of the alkyne group, the number of alkyne group increases, means the acidic character it is going on decreases. That is one point. And next we have seen about the preparation of a nitro compound. Okay, so today we are discussed up to that preparation only. Any doubt you can ask. Students, any doubt you can ask. No? Open your speaker if you have any. Then we will rectify your doubts in that. I hope you are clear. Okay. Anybody? Open your mouth and ask. No one is opening. All are present. And, they are not at all opening. Why? Students. Okay. If you have any doubt, you share with me. Thank you.